the first thing we're going to talk about is solids. Okay, what are the molecules like in a solid? Leslie? Yeah, they're packed together, so they're all close. Okay. So what are those molecules? How do they behave? Or how do they move? Yeah.
They move back and forth.
So like you're talking about, like they move positions?
No, they just move like.
Okay. Okay, so they good, yeah. They vibrate is the word that so meaning going like shaking, right? Vibrating. So everyone feel your desk. Feel it vibrating? No, right? So those vibrations of the molecules are so minuscule that you have to have some extreme ability and feeling to be able to feel the vibrations of the molecules. So this motion is not very big, very, very tiny amount of motion, but it is still there. It is still motion, and it just vibrates in place. If it were to completely stop, we call that absolute zero. So absolute zero is when you pulled out all heat and energy from something, and so it completely stops. And scientific theories say that if you were ever to reach absolute zero, which we never have, but if you were ever to reach absolute zero, that would stop time, at least for those molecules. And so, like, if you could ever put a person into absolute zero, that would be like the cryogenesis thing that they always talk about on sci-fi movies, where they can sleep for 100 years and then wake up and they haven't aged at all. That's the idea of absolute zero. They can place their molecules in such a slow amount of movement that time doesn't really pass for their body. Okay, so liquids. What are the molecules like in a liquid? Liz? Okay, so they're a little more spaced out. Still pretty close together like solids, but a little more spaced out. Okay, and what do they move like? Eddie, what do you think? Okay, so liquids, they have a small amount of motion, and so these molecules, or they, not small amount, they have motion, and so those molecules move around, but most of the time those molecules don't have the ability to move anywhere they want. If we were to put some liquid molecules on the table, they wouldn't have the ability to go upwards, right? They would spread out on the table, and generally they'll stay close together. So solids stay tight, packed, and vibrate. Liquids move freely, stay close together, so they move freely and stay close together. So they're not stuck in one spot. They'll be moving all over the place, but they still stay close together, and they are limited in where they can go because of gravity and the shape of their container. All right, last one, gas. How does the gas move? Yeah, Calissa? Yeah, it's super spread out, and it moves to all the space available. Okay? In all directions. Okay. And so gases, if we had a balloon full of some noxious gas, like it makes you sick, and we pop the balloon, in a matter of like minutes or less, it would spread through the entire room. Because those gas molecules can move anywhere as long as they're not trapped. And so gases, whenever you introduce them into a new room, you expect they're going to fill everything. That's part of why you can smell a skunk that got killed on the road from a mile away. Like, you know how you cross over and you like suddenly start smelling it, and then it stays with you forever? It's because those gas particles are able to spread out so much and move such far distances. We actually, I can't remember who it was, but another person was wondering about how fast gas particles move, and we've actually found out that they move 300 to 400 meters per second on average, which is about 1,080 miles per hour. So gas particles are moving really, really fast. You don't really notice, like, you would think something moving that fast if it were to hit against you, like gas molecules are always doing, you would think you could feel them, but because they're just like with the table, it's so microscopic that it still does not have enough force to actually feel it unless it's really strong, like the wind. Once it starts moving extra fast, that's when you can start feeling it. Okay, so